All right, last video. There's just a couple of things on this page that we want to go over. So reflection, the law of reflection. So let's say we've got a mirror, okay? We've got a light ray coming in and it's going to bounce off of this because this is a highly reflective surface. Okay, so you only have this scenario in certain cases where you've got something that's reflective. I used a reflective transparency paper in our classroom to show you all this. But if you've got a perfectly reflective material here, you've got an incoming ray, it's going to hit this and bounce off, okay? And so the angle of incidence, this incoming ray, this angle it makes with our normal or our perpendicular line equals the angle of, in this case, it's reflection. Okay, this isn't refracting. It's not going into this material or bending. It's just coming in and then bouncing straight off and going the other way. Okay, so if we have reflection of a light wave, the angle of incidence equals the angle of reflection. That's the law of reflection. So hopefully that's pretty straightforward. So you're going to have an angle coming in, angle going out. These two angles are equal to each other. Okay. All right. And then the last thing, polarization. So this is a different polarization than anything that has to do with protons and electrons and electrostatics. Okay. Here we're talking about light being polarized. So we said that electromagnetic waves, they're called electro and magnetic because they have two components. And I'm going to be terrible at drawing this, but you basically got one component that's, you could think of as like up and down, and then you've got one that's parallel. Okay. And I showed y'all a slide of this, which is a much better graphic than what I'm drawing. Okay, you've got two components that are perpendicular to each other because they've got an electric component and they've got a magnetic component. Okay, so they've got like one direction this way and then one direction this way, if you can picture that. Okay, so that means that light, all electromagnetic light waves have these two components. Okay, if we, and that's what being polarized means. Okay. So if we want to separate those two components, okay, really polarized, they have the two components, and then polarized is where we separate one component from another. And this is something I'll go over as well in class because we only spent a little bit of time on this. But what happens with a polarizer, and this is what's included in, say, your sunglasses, for instance, okay? A polarizer or a polarizing filter separates the components, and it only lets one pass through. Okay, so in the case of this filter, for instance, we're pretending this fence is a filter. It's up and down. It's only going to let this up and down component go through. This parallel or side to side component will be blocked. Okay, so with sunglasses, you've got all this light coming in from the sun, and it's got an up and down component and a side to side component. Sunglasses are going to block one of those two components. So they actually help give you, they make it easier for you to see on a sunny day because they're blocking out one of the components of light. So the light is not as bright. it's also, they try to block the component that's more harmful in terms of like other invisible light, like UV light hitting your eyes and damaging them. Okay, so polarizing filters in sunglasses are, they help us see better. They also help protect our eyes. Okay? But the point of polarizing is you've got these two components of electromagnetic waves, an electric and a magnetic. So, and these two components are perpendicular to each other. So you've got one that's like up and down, you've got one that's side to side. And to be polarized means you're separating one of those out. Okay. So you're only letting one of those two pass through. So you're taking those two components of the electromagnetic wave and blocking one of them. So only lets one pass through and blocks the other. And we have polarizing filters that I showed y'all in class, where if you tilted them, like a 90-degree angle to each other, you blocked out light. I'll show y'all that again as we go through review. So, okay, that is our light wave study guide.